Scientific methods of dating. Determining the age of a rock, fossil, or artifact is one of the primary goals of geologists, paleontologists, and archaeologists. In the past, specialists in these disciplines could, at best, make educated guesses regarding the age of a particular object. This is because the only techniques available to them were relative dating techniques. As the name suggests, relative dating allows one to say that an object is older or younger than other things, but it does not reveal an object's actual age in years. Over the last century, however, scientific progress has led to a wide range of absolute dating techniques that can tell researchers how many years old an object is with varying degrees of certainty. What dating technique a researcher uses depends on a variety of factors, including what material the sample is made of and the approximate age of the sample itself. For instance, when large pieces of wood are available and require dating, such as those used to construct buildings or ships, a technique called dendrochronology can be employed. Although the process is quite complicated in practice, the basic concept is quite simple. It is well known that as trees age, the amount of growth varies from year to year depending on the local environmental conditions at the time. These variations create unique patterns in the wood that can be linked to specific calendar years. Moreover, by looking at trees whose ages overlap, scientists can build up a continuous record of tree rings for a local area, sometimes going back thousands of years. By comparing a sample of wood to the local record, scientists can often determine with a high degree of accuracy when the tree was cut down. Besides being limited to wooden objects, the main issue with dendrochronology is that relatively few regions have excellent records of tree growth over the centuries, thus limiting where the method can be used. A more widely used technique in archaeology is radiocarbon dating. This dating method can be used when there is organic material available, such as a piece of bone, a scrap of cloth, or a preserved leather sandal. Radiocarbon dating takes advantage of a very useful observation. When an animal or plant is alive, it continuously absorbs a radioactive form of carbon called carbon-14 from the environment. The concentration of carbon-14 remains the same until the organism dies. After death, however, the carbon-14 breaks down at a constant rate. As a result, by measuring the concentration of carbon-14 remaining in a sample, scientists can state how old the sample is, often within 100 years of the true date. Radiocarbon dating becomes less reliable the older a sample is, and is limited to objects less than 50,000 years old. In addition, organic samples can become contaminated in certain environments, so scientists also have to take this into consideration when using this technique. Beyond 50,000 years, scientists have a range of dating techniques available, most of which depend on some kind of radioactive decay. For example, a method known as uranium-thorium decay can be used to date certain organic samples ranging from about 40,000 years old to 500,000 years old. For rock samples that are more than 500,000 years old, one of the most commonly used dating methods is argon-argon dating, which measures the decay of potassium into argon. Unlike radiocarbon dating and uranium-thorium dating, argon-argon dating actually becomes more accurate the older a sample is. In the last few decades, scientists have developed even more dating techniques such as trapped charge dating that give them even more ways to date ancient samples of various ages. It is important to remember, however, that scientists often use a combination of relative and absolute dating techniques to estimate how old an object is. For example, it may not be possible to date a fossil directly for various reasons. In this case, researchers depend on using absolute dating techniques to measure the age of rock layers below and above the fossil to give an approximate age of the fossil. At the same time, whenever it is possible, scientists will try to confirm the date of an object using a wide variety of methods. For instance, if a dendrochronology analysis of a piece of wood from an ancient ship gives a date of 1,000 years old, scientists would try to use radiocarbon dating and relative dating techniques to confirm that date.